Hello, hello, hello. It is I, Jihye. I'm here, I'm here. Good evening, Astro. Good evening, Blue. Good evening, Yak. Just a reminder that today, there will be some reminders coming up throughout stream, but a reminder that today is, in fact, a family-friendly stream. The content that I'm producing on these Britesparks Hagwon streams is likely to attract a younger audience, and so therefore I am kindly asking everyone in chat to support this. Today, I am actually going to pin a message to that effect. Please remember to keep everything family friendly today. Okay, and let's pin this until the end of stream, just to be on the safe side. I know I'm normally safe work, but I'm definitely not normally family friendly. I'm safe work for adults, but not really normally welcoming. But the type of content I'm making is just likely to show up in searches for young people, and so therefore I would like us to keep it clean. Keep it clean, 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 clean. It will also be a short stream today. This is a education stream. It's going to be like a short lesson. So for those of you who are not aware, Britesparks Hagwon is my education streamers project, and I am in the faculty. So I will be covering STEM topics, PSHE, ESL, and debate in varying streams. And we're starting with some STEM. And we're going to start all the way from, we're not going to go all the way back to baby primary school, elementary school, but we will start at about 11-year-old in secondary education. So we'll be starting there in the UK and going all the way through to 18 in secondary ed UK systems, which is about first year of university for Americans, roughly, give or take in places. Hopefully it will be interesting for some of you. I know some of you are here for my gaming, chatting, etc. content. This might not be for you, and I totally understand that. Respect. So, I guess because it is an education stream, we will probably dive right in. Yeah, it's got to be family friendly today, I'm afraid. If that's not your bag, that's fine, but that is what this stream is about today. The cats will still be with me. I think a classroom pet is a perfectly valid thing for us to have. And today we're going to be talking about the particle models. So I guess let's start with a little roll call. Who have we got? Who have we got? Astro. Hello, Astro. How you doing? You still there? Better be. Fight you. What about you, Blue? Are you still there? Well, I knew doing different content would be a stretch. Okay, Astro. So I have one star pupil. Excellent. Gold star for you. Who else do I have? What else do I have? Just you for now? Oh, okay. It's all right, guys. We're going to soldier on. We're going to soldier on. You are guys going to learn things. Or probably not today, because we're starting at real baby level. So you guys can just flex that you already know things. That's what you can do. Let me see if I can summon a cat for you as well. Remy. Oh, wow, you really are having none of it today, Remy. Okay. I just got given the look of death, guys. The look of death. Okay. Let us switch. Let us switch to... particles. Woohoo! Okay, so, Astro, as you are here, fun fact! This is our fun fact. If people were the same size as gold particles, the world population would fit into a ball less than 1,000th of a millimeter across. What does this... Oh, hello, Sola. She's here for the learning. Yeah. What does this tell us about particles? What can we tell about particles from this? If people were the same size, the world population would fit into a ball less than 1,000th of a millimeter across. What can we infer from that? Any ideas? If you're watching this as a VOD, take a little think, see if you can get your idea and see if it'll match in a second when I share the answer. Okay. Yeah, so they are very, very small. So particles are very small. Okay. A gold particle, if we were all the same size as a particle of gold, then the entire population of the world would fit into a ball that is less than a thousandth of a millimeter, not even a thousandth of a centimeter or a meter, a thousandth of a millimeter across. That's really, really incredibly small. Some key words. I know that some of my viewers are not native English speakers, so I just want to quickly go over some keywords I'm going to be using today. A material is a specific type of something's made of. So wood is a material, gold is a material. They can be elements or compounds, mixtures, they can be all sorts of things. But if we kind of view it as one substance in our day-to-day life, it's a material, something we can use to make things. Plastic is a material. Okay. Particle is a bit of an odd word. Particle just refers to like the makeup of something, the little objects, the microscopic objects that make up something. And there are different types of particles that we will learn as we go through. A mixture is when you have different types of particles that are not chemically bonded with each other. Okay. We will come back to that a lot more in a later lesson. Properties are the things that make a substance what it is. So gold, a property of gold is that it's shiny. A property of gold is that it's soft. A property of Jihye is that she has red hair. They're the things that make something what it is. And a substance is just a thing. Really, it can be almost anything. Is a substance. Something that makes things up is a substance. These are all really vague words, and as we go through the topic, we're going to learn more specific terminology for each thing. So we're going to learn to break down different types of substances, different types of particles, different types of materials. But just so that we're aware that these words are these vague words and we know roughly what they mean before we work through. I think it's important. So we are going to be able to describe how materials are made of particles, and we're going to be able to use the particle model to explain why different materials have different properties. So I love these cool did you knows. Did you know that welders have to wear protective face shields to protect them from welding sparks? But those welding sparks are actually hot metal particles. I think sometimes people think sparks are like fire, but these particular sparks are actually metal particles that are flying off of the welding surface. The reason they look red or yellow or orange or even white is because of the amount of energy they're carrying. So if they're carrying an amount of energy, that means they can actually emit visible light. But that's the way they look that color. But actually, they are hot metal sparks, just very, very hot, carrying a lot of energy. It's very weird teaching you guys. Please do at any point, by the way, if you have any questions or any interesting thoughts, feel free to interject into the lesson and post them up. Oh, here we go, immediately. So not only does it blind people, it also harms them physically. Absolutely, yes, you will get physically burned by the sparks. You will get scarring from the sparks if it hits you. Absolutely. Good question, Astral. Good question. So materials are made out of tiny particles. So a material is made out of a tiny particle, and particles make up everything we see, but they are too small for us to see individually with our own eyes. So here are some examples of some materials, okay? We have wood, brick, we have a cigarette butt is a material. We have all of these things are materials. They're all made up of particles, and they are all too small for us to see. What I want you all to do is just, wherever you are right now, just take a moment. I'm going to give you probably actually 30 seconds because we're on stream and it'll be weird and awkward if we come in and I'm silent. But I'll give you 30 seconds. Look around you, and you can either physically list down if you have a notebook, or you can open up a notepad document on your computer, or if you don't have access to those things, just do it in your head. Can you make a list of as many materials as you can see around you? Let's see how many we can get. I'm going to do it too. Okay. How did we do? I got up to 9. I actually found it harder than I thought to come up with differentiated materials. What about you guys? Anyone have any more success than 9? No, just me. So you could have had things like plastic, metals. You could have had things like, you could have been more specific, metal foil, stainless steel. You could have said different types of plastic. Thank you for the mid-lesson hydrate there, bloop bloop. I appreciate it with all my heart. These are all materials, and every single one of them is made up of particles, very, very, very small building blocks that are too small for us to see. But they are all made up of particles. There is not a single material that is not. Okay. So there's millions of materials. Okay, here's a few. What do all of these materials have in common? We just said they're all made up of particles, every single one. These ones are mixtures because they are made up of different materials. Aluminium foil and stainless steel. Yeah, good. Bread is a material. Well done. It is a mixture. So bread is a mixture. That means there are different types of particles in here that are not chemically bonded with each other. So blue, your bread is a celebrity in this lesson. It is a mixture. It is made of particles and it is wonderful. Wood is a mixture. Okay, it is a mixture because it is made up of different particles that are not chemically bonded to each other. Bronze is a mixture. So a lot of people don't think about this, but alloys. Alloys are a mixture. Alloys are when we take different metals and we mix them together to get combined properties. Hello, Hashiro. Hello, hello. Welcome to stream. How are you? How are you? Well, the only classes you'll ever go to where Keanu Reeves might occasionally just make announcements during class time. So we have, oh no, classes again. Yes, but it's classes with Jihye. That's clearly the best blue. So bronze is when we take two metals and we mix them together to mix their properties, but they don't chemically bond with each other. Milk is a mixture. We homogenize milk because the mixture is actually very visible. Yeah, see, these are all things people don't think of as mixtures, but chemically they are mixtures. Colloquially, the way we speak in English, of course they're not, right? We think of a mixture like a cake mix. But in terms of the chemical terminology, they are in fact mixtures. Still, class is blue, but you don't, if you're genuinely a bit traumatized by class, I will not guilt trip you to stay. I'm teaching you the big words, blue. We're learning the big words, so that you can flex the big words to people. So, air is a mixture. When you breathe in emulsification, yeah, mayo is a mixture. Mayo is a perfect mixture. Any emulsifier, anything you can emulsify is a mixture. Yes, yes, absolutely. You get it. You've got it, Astral. You've got it. See, gold star student. I knew you would be. Air is a mixture. So here I have made a very high-tech diagram of air. Who can, like, can you see why this is a mixture? Yes, butter would be a mixture, yes. So butter is a mixture. Not a very exciting mixture because it's predominantly milk, but it is a mixture because milk is a mixture. What makes this a mixture? Why, when we look at air, is it a mixture? Be brave, take a guess. There's a clue on the diagram. Yes, blue, gold star. I should actually keep gold stars for you guys, right? I should have some kind of point system going. I should set up a Class Dojo account or something. Yes, so different particles or elements, there's both, yes. We'll get to in a later lesson the difference between those if anyone doesn't know. But blue is absolutely correct. We have nitrogen and oxygen, they're elements. We also have water, carbon dioxide, they are compounds. We have argon, we have all sorts in our atmosphere. It is a mixture. It is a mixture of different particles. Remember, any particles. When we're talking about a mixture, we don't have to be specific about element or compound. We can just say that it's when there are a number of particles that are not chemically bonded. So when we look at our diagram here, we can see that this water is in no way connected to this oxygen. They're separate. They're just next to each other. That's how a mixture works. There's no chemical bonding. It's just together. So here, this water is not near this oxygen, okay? They're not connected. Where they're touching is where there's a chemical bond. There's no chemical bonds here. So it's a mixture. Good job, Blue, good job. A mixture is made up of many substances. I will remind everyone, because this is my first stream on this one, if you're watching the VODs or you're playing along in chat and chatting along, please do feel free, if you're here genuinely to learn, like you are studying as a student right now, or you are just generally interested in catching up some knowledge you think you didn't have, then you are welcome to make notes as you go through. If I'm moving too fast and you are taking notes, the VODs will go up after stream, or you can just ask me to slow down in stream. I am going to be teaching a bit faster than I would in a class because we're on stream and most people are just here to kind of chat and soak up the knowledge a little bit. Okay. Anyone know how to say this number? 3, 6, 9, 12, 15, 18, 21. 8.4 times 10 to the power of 24. Water particles in this glass. That's a big number. I have no idea if it's a quintillion. I'll be honest, I get above a billion and I stop caring. I start using standard form. But I'll take your word for it, guys. This could be a quintillion. Water particles just in this one glass of water. Thinking back to the beginning of the lesson, what does this tell us about particles? What do we know about particles from the fact that there are 8.4 times 10 to the 24 particles in one glass of water? What can this tell us? It's not a trick if some of you are thinking this is too simple, too obvious. Nope, it's not a mixture of the same element. It's just that they're so very, very small. So incredibly tiny. One of the things I think we often just don't really grasp truly in our hearts is the sheer scale of how small some of the things we study in science are and how big some of the things we study in science are. And one of the key parts of the curriculum that I work within is getting students to understand the scale of what we're learning. A particle is incredibly tiny. They're not just a little bit small. They're not just a bit smaller than we can see. They are very tiny. For the record, Astral, water usually is a mixture because it usually isn't pure water. It's very rare that water is truly pure. There is usually other atoms and ions in it, but we will get to that when we get onto mixtures in more detail. Pure water is a substance. A substance is typically something made of one type of material. And this is where science gets a bit complicated, because a material is a very vague word and a substance is just made up of one type of material. So if I have a lump of stainless steel, it is a mixture because it's an alloy. It is also a substance because it is just made up of stainless steel. So it's made up of more than one type of particle, but only one type of material. Whereas my phone is not a substance because it has many materials making it up. Solar here is not a substance because she's made of many, many, many materials. Aren't you, Solar Polar? Thank you. These vague words are horrible. Scientists hate words like substance and material because they are vague and because they are confusing. But you will hear them in general English language. So it's important to at least know what they are so that it doesn't confuse you. Okay? But in science, we try to be more specific and we try to use the words that actually describe the thing. Okay? Iron nails are a substance. Gold is a substance. In a substance, all the particles would be the same. Okay? Materials are made of particles. Materials are either mixtures or substances. In a substance, all particles are the same. Okay? That's the breakdown. So materials are made of particles, mixtures, or substances. If the things are separate, then it is not a substance or a mixture. If they're completely separate, it is not a substance or a mixture. If they are together and the particles are different things, then they are a mixture. If they are one particle, that could be an element or a compound or whatever, then they're a substance. See how easy it is to get yourself muddled up? So many keywords to know. Mixtures are just many substances that are together. Just going to give a second for people who are processing. All right, Blue, have a fantastic evening. Thank you for popping in. And if you are watching via VOD and you need more time to process, please remember that you can pause the VOD at any time. So, are we ready? I'm going to give you some time first. So if you are someone who is trying this by yourself, or if you are someone who is watching this in a VOD, I recommend that you pause and complete the task. And then when you unpause, you'll be able to go through the answers together. If you're doing it as we watch, then I recommend that you get whatever you're scribbling some notes on now, and you can just write down the word that you would choose for each option. Okay, you don't need to copy it all out. If you want to do that, I recommend the best way to do that would be to go back to the VOD later and create some notes. If you're a quick writer, feel free to write it all out if that's what you wish to do. Or you can just have a look through and have some answers ready. I just don't want to scare anyone with immediate answers. Beautiful. Just going to give you a few more seconds. Again, a reminder that on stream I will be moving a little bit faster, but if you ever need me, then I would in a lesson. But if anyone is ever doing some serious study from something I'm talking about, please do ask me to slow down, give you some time. Okay. All right, chat, are we ready? Impress the teacher time is beginning. All materials are made from substances or particles, which is the correct gap for the first gap. All materials are made from substances or particles. Which is it? This is so much less awkward when you're in front of a class, I'll be honest, chat. Substances or particles? Particles. Oh, Astral, you're my gold star student tonight. What's this, man? And there are hundreds or millions of materials. What do we think? Hundreds or millions? Hundreds or millions? Do 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 do. Da 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 da. I'm gonna help you guys out because I know we're a bit thin on the ground tonight. New stream type, to be expected. It is millions. There are millions of materials. Okay, there are 3 or 2 types of materials. 3 or 2 types of materials. There is 2 types of materials. What are the 2? Out of here, what are the 2 types of materials? You just stop counting when you reach to a million. What are the 2? Yes, look at you go. Mixtures and substances. In a substance, all the particles are the same or different. In a substance, they're the same. And in a mixture, mixtures are many substances together. So in a substance, it's all the same particles, and a mixture is different substances together. Okay? Which ones are examples of substances from wood, water, gold? Which ones are examples of substances from wood, water, and gold, do we think? Okay, so water is a substance. Okay. And gold is also a substance. It's only made up of gold particles, so therefore it is a substance. And in milk and iron nails, milk is a mixture. Iron nails is a substance. They're only made of iron, only one type of particle, so it is a substance. Milk is a mixture of substances. Okay. I'm just going to leave this up for a few seconds. If you need to check your answers, especially those watching in a VOD, please pause for a moment now until your answers are checked. For those in chat, we are going to move on. All materials are made of particles, and there are millions of materials. There are 2 types of materials, mixtures and substances. In a substance, all the particles are the same. Mixtures are many substances together. Water and gold are examples of substances. Milk is an example of a mixture. Okay. Whew. How are we feeling, chat? How are we feeling? We're about halfway. We're about halfway through our first lesson. I hope you're probably understanding why these streams are going to be slightly shorter. I have debated just recording these as videos, and if the feedback I get from you guys is that doing them as a stream is just super inconvenient and you don't like it, you'd rather just have them as VODs, I'm happy to consider it. But the feedback I initially received is that streaming them and having the VODs would be the preferred option. So I'm going with that for now. But it is... yeah, it's tiring, so we're only going to do about an hour at a time, give or take. Okay, so we can now describe how materials are made of particles. We've achieved that. Our first objective from today's lesson was that we'd be able to describe how materials are made of particles. So now we need to be able to use something called the particle model to explain why different materials have different properties. And actually, I think the particle model is the easier part of this lesson. The first part is just very much knowing the vocabulary. Once you've learned that vocabulary, it's great, but if you don't know that vocabulary, it's a bit bewildering. But the particle model is common sense, and you will have, those of you who are graduated from high school have learned it at school. Whether you will remember it is a whole other question, but it shouldn't be completely new to most of you. I say most of you, the world's curriculums do vary, but the particle model should be on pretty much every curriculum in the world. So, we talked about this word at the beginning of this stream, property. A property in science describes what a substance looks like or how it behaves. So remember I said Jihye having red hair is a property of Jihye. A property of gold is that it is shiny and soft. A property of Pepsi is that it is delicious. Just kidding, guys. Just kidding. So properties of a substance depend on three things. Three things can affect the properties. Number one is the arrangement of particles. Number two is how the particles move. And number three is what the particles are like. So here we go. Water, rubber, paper. There is a list of properties above under an easy, medium, and hard list. All I want you to do is organize all of those properties, the easy, the medium, and the hard. Do they apply to water, rubber, or paper? So you can do it as a table, water, rubber, paper at the top, put the properties in. You can just in your head have a look through it now. You can write out all the properties and just put WRP next to them, whatever works for you. Again, a reminder that if you are watching this as a VOD and you want the time to do this properly, please pause the video now and unpause it when you're finished. If you're watching on stream, feel free to try and make the notes as we go through, or you can go back and look at the VOD. But what do we think? What do we think? I'm going to give you 30 seconds pre-thinking time before we discuss, so you can have a bit of time to process it. Okay, so flexible. Which ones would you describe as flexible? Water, rubber, paper. Is water flexible? Is paper flexible? Is rubber flexible? Ooh, okay, I like your thinking. What about, let's pick I'm not going to do them all, I'm just going to pick a couple, okay? I'm just going to pick a couple. What about waterproof? Which would you pick? Water, rubber, or paper? Rubber, okay. Now let's pick one from the harder list. Oh, who knows what malleable means? Malleable. Who knows what malleable means? Malleable is such a good word. I love teaching it to students. It's one we need for scientific properties. Not so much mold. It means you can beat or stretch something into a shape. Ductile means you can pull it into a shape. There's different words for specific behaviors. So which of these do you think might be malleable? Which ones might be malleable? Such a good word. All right, and I'm going to pop some answers up for us. Ooh. Here we go. So, water is hard when it's ice, sharp when it's solid. It has a low boiling point. It can conduct electricity. It's slippery, low friction. It's a solvent. It's reflective. It's transparent. Rubber is flexible, elastic, light. It can be colorful. It can burn easily. It's waterproof. It can be melted. It's an insulator. That means it doesn't conduct electricity or heat, one of the two. And it's opaque. That means you can't see through it. Light is not transmitted or transmitted through it. Then we have our paper is smooth and light. It's colorful and it burns easily. It's also malleable. You can change it into a shape. Okay. Rubber can be stretched, but not permanently to change its shape. Okay. When you're stretching it and moving it back, it will return to its original shape. And paper is also opaque. Again, it does not transmit light through. For the most part, the type of paper that's pictured, at least, can get a bit complicated with paper. It can get a bit tricksy. So, substances have their own properties. And I have here some information, some data about gold and water. And all I want you guys to do is putting this data into a table. So I've given you an example of the table. The words in quotes would be the headings, and then the table would be filled in. Again, if you're watching from a VOD, this is where you would pause and please complete this exercise. Though if you are watching now, I'm going to give you a few seconds to think, and then we will go through it together as a team. So the first word we have in quotes is substance. So what data do we have about a substance? So we need to know their relative mass. Sorry, substance, but relative mass and their mass of what? And their mass of 1 centimeter cubed of the substance in grams. Okay, so their relative mass and the mass in a certain volume for gold and for water as the substance. So for gold, first of all, what is the relative mass? You don't need to know what relative mass is to even be able to do this. You just need to pick the information out. Okay, I'm going to give it another 10 seconds and then I'll pop the answers up for yourselves and for the VOD. Okay, so this tells us the relative mass of the particle and the mass per 1 centimeter cubed. So you can tell that if I have 1 centimeter cubed of water, I actually have a much lower mass of the water. Hello, Katsini. Hello, 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 hello. Meowdy, how are you doing? So my question, first of all, I guess, is who knows what mass is? Does anyone know what we define mass as? What is mass? because I'm talking a lot about mass, but we haven't brought this word up before, and I've just thrown this in here. What is the mass of something? This is a really common misconception, a common area that people don't understand is what the mass of something is. Oh, okay. Excellent, Astral. So we would think of it as how light or heavy an object is when we talk in plain English. But actually, light and heavy is weight, right? When we're thinking about light and heavy, we're really thinking about weight, the force that it's applying. The mass is the amount of particles, the amount of matter, the amount of stuff in an object. And I know when I say the amount of stuff in an object, that sounds vague. Well, that's what matter is. It's the stuff that makes us up. And the amount of stuff, the amount of particles, the amount of matter inside us is our mass. Okay? When we say we weigh ourselves, we are actually taking our mass. So one of the reasons this is so commonly confused by students is I say, I weigh X number of kilograms. But kilograms isn't weight, it's mass. It's the amount of particles that make me up. Now, how heavy I am is dependent on the number of particles and the gravitational pull where I am. That's my weight. So my weight is different. But in English, when we're outside of a science environment, we might say my weight is, and then something in kilograms. But scientifically, that's incorrect. My mass is in kilograms. The amount of stuff, the amount of particles, the amount of matter in me is measured in kilograms. My weight is measured in a different unit. My weight is a force. And when we're talking in English, separate to our science situation, it's perfectly okay to use weight in both those scenarios. But when we're in science, we define them separately because they have very different uses, meanings, and they tie into other areas of science, and we need to be using the right one. Oh, I love how you got it right, and you got me to talk about something I'm passionate about. Hi, Cassini. We're doing science today. It's my education streams are back. I'm curious to see how they will go with my usual audience, but they are back. Today we are learning very beginning of secondary school particle stuff, but we're taking our time. We're learning it properly. We're reminding ourselves things we might have forgotten. Okay. So will gold float? This is the information we know about gold. It has a relative mass of 197. And it has a relative mass of 18 in water. Mass of 1 centimeter cubed of gold is 19, and the mass of 1 centimeter cubed of substance is 1 gram. So, will gold float? If I had a lump of gold, chuck it in some water, will it float? You think it will? You think gold floats? Anyone else? What causes something to float? That's my second question. My follow-up question is, why do some things float? What makes things float? Have you ever really thought about why some things float before? Do we just accept it? Hopefully people who make boats don't just accept it. It is how dense something is. How dense, but what is important about its density for it to float? So let's say if I'm in water, because I know we can float in different substances, right? So if we're in water, what would we have to know about the density of an object to know whether it would float in water? So it is in fact their density compared to water. So for something to float, it must be less dense than what it is trying to float in. In this case, water, it must be less dense than water. And density is a measure of mass in a certain volume. And we have this here, mass in a certain volume. Mass of 1 centimeter, mass in 1 centimeters cubed. The mass of 1 centimeters cubed of substance is going to give us a clue what we're looking at. So gold cannot float because the particles of gold have more mass in the same area than water. So looking back, in 1 centimeter cubed, so in the same volume, water would have 1, gold 19. This is a higher mass in the same volume, so therefore it will sink. If it had a lower mass than 1, if this said 0.2, then gold would float. If you take the same volume of two substances, work out the mass in that volume of each, then the one with the lower mass would float in the other. That's the rules. You just need to float. You just need to have a lower, sit down cat, a lower density. Remy's really into the learning right now. Remy wants to learn, damn it. He just wants to learn. Okay. So, you can find relative mass on the periodic table. Centimeters cubed is a unit of volume, so we know this is volume. This is the reason oil would float, yes, is because it's density. Yes. For any given volume of gold, particles are heavier. So any oils that are more dense will actually sink when they separate, and they will settle under the water, and the water will float on top of them. It's a really good question. Really good question after all. Okay. So we can describe how materials are made of particles, and we can use the particle model to explain why different materials have different properties. Okay. Key facts. All materials are made of particles, and all materials are either mixtures or substances. Materials have property which depends on the substances inside them, and the factors that affect properties are the particle arrangement, how they move, and what they are like. Okay. If you are someone who is making notes on a VOD, please pause the VOD now. You can make your notes. I'm going to move on quite quickly on stream because, well, we're not just making chat. So, that is actually it for our first lesson. How do we feel, chat? Should I keep doing these as a live stream and VOD, or should I just record them as VODs for people? I quite like the live stream. I like being able to ask you guys questions, even if there's not enough people around to answer every single one. And I like, Gastro, you had some good extra inputs, which was nice. But if you feel like these streams are just... Did you just go up to the camera to yawn, Remy? What a man. Then please do let me know. We're going to be finishing this series on particle behaviour, which is just what we would call in the UK Key Stage 3 knowledge. So that is lower, that would be middle school, I guess, in most of the world. We will finish that, and then we'll also do some other topics. I have some biology topics, some other things to mix in, and we'll just keep alternating through the 3 sciences and the other things I'm teaching so that we aren't stuck on one topic for too long, and we're going to slowly move up to higher level stuff. But I want to make sure I have VODs of the lower level stuff for people who maybe need to have a little bit of background before I dive into A-level physics, for example. I'm glad you learned some interesting things tonight. I will pet the catto, mostly because he's trying to get on the desk. Get down, demon child. Thank you, Demon Spawn. Very short stream. I did say they're probably only going to be around 50 minutes to an hour each stream, because they are designed just like a school lesson, and honestly, learning is exhausting. So if any of you are showing up to actually learn, you're going to be tired. Please give me any feedback. Would you prefer I do double lessons, so we do 2 lessons and it takes around 2 hours? Any feedback you have would be welcome, including people watching on the VODs. Please feedback and let me know what you need or want from it, and I will see you again for my next Britesparks Hagwon stream. Thank you.